Hello, Terry. This is Aaron. I thought I would explain to you what I'm doing. I downloaded the life tables for Nova Scotia. I found them on StatCan's website. And similar to the lecture where I explained how life tables work, what I have to do special for your case is what I do the projection based on is based on the annual probability of death. So this is the annual probability of death at each year of age. So they have it for each year of age, which is fantastic. But the way they have their data set for just 65 years and older, which is the group I'm going to focus on primarily, I'm going to have to, instead of just looking at 65-year-olds, I'm going to have to look at 65 and older. So instead of just the probability of death at age 65, which is 0.02, I'm going to have to figure out what the probability of death for 65 and older is. So in order to do that, we do a weighted average. So to get a weighted average, this is the number of people that survive, 83,000 in this case, and each of them has this risk. So I multiply the number times the probability, and I get this. So this is a simple thing in Excel. Excel can do the math for you. When I clicked on this cell, you can see it's using data from this cell multiplied by data from that cell, give me a number, and I just repeat that formula over and over and over again. So I get the total sum of the probabilities of death, and then I divide that sum of the probability of death by the number of people to get the weighted average. So overall, people 65 and older have a 0.059 risk of death. That's just on average. 65 and older, that's the rate of death. And the same thing for the 80 plus. In Canada, you guys report the data as 80 plus here, seniors 80 and older. So I did a weighted average for the 80 and older, and so for those that survived 80 and above, the weighted average is 0.129, and we do it separate for males and females. So this one is for males, and then below for females. Female mortality is always lower, and gladly here's 0.05 for males, it's 0.049 for females, 0.12 for males there, 0.10 for females. So I've got confidence that these numbers are right. So now what I'm going to do is I need to get the data from the StatCan website. So here's the data, and it first reports it as both sexes, but for the population pyramid I want to do males and females different because the risk of death is different for males and females. So I need to make sure we change the gender, and I chose Cape Breton for now just as a starting point. So Cape Breton, males and females, and we're going to ignore the 15 to 64-year-olds. Actually, I would have loved to do something with them, but it's such a huge age category. To get the average risk of death, 15 to 64 is almost meaningless because it's such the wide age range. So I'm just going to type in those numbers for the age 65 and 80 plus for males and females. So 65 and 80 plus. Okay. And Excel has a funny way of identifying if it's a number, it puts it on the right. If it's a text, it puts it to the left. Okay, so Cape Breton, I put 8,395 people 65 and older, and 1,770, oops, I put the number in the wrong place, 80 and older. Okay, now I change it to females, submit. And same thing, we know 65 and plus is 11,260, and 3,485 females 80 plus in Cape Breton. Okay, so here's my population, and I know that each year for males that are 65 and older, they have an annual probability of death of 0.05, and for females 65 plus, it's oops, no, this is I made a mistake. Okay, I want to stay one gender at a time. Staying with males, and I was a little bit off your screen there. Okay, so basically I just told Excel by putting an equal sign and clicking on the cell to just copy that number. So this is the annual risk of death for males, and this is the annual risk of death for females. So I'm going to press equals and do my 65 plus and equals my 80 plus. Okay. So here's the way it works. And these are 15 years apart, right? The difference between age 65 and 80 is 15 years. So I'm going to do a 15-year projection. So we're going to start with 8,395 males. And in 1 year, so in 1 year we multiply the number of males by the annual risk of death. And I clicked in the wrong spot. So equals cell, it's already wrong, equals this number, which is cell C282, multiplied by the annual risk of death. So if this was in the year 2011, we had male 65 plus. In the year 2011, maybe I'll add a row. In the year 2011, we had 8,395 survivors. Then we would have this many deaths. If we lose about 5.98% of them is 502 deaths. So we're going to subtract, we're going to take the survivors minus those that die, and this is who survives in 2012. So the original 8,395 are now down to 7,892 survivors, who are now 66 and above. So actually the risk of mortality should increase slightly, but I'm going to ignore that for now. And equals this multiplied by the annual probability of death. And so this is how many deaths we have. So then in 2013 we do the survivors minus those that die. This is how many that are left. So I just repeat this cycle over and over and over again. And I'm just going to pause the video briefly while I do the math.